We are dealing with applications and we need to convert to standard normal distribution SND using the formula z equals x minus mu over sigma. So the area in any normal distribution bounded by some score x is the same as the area bounded by the corresponding z-score in the standard normal distribution. For example, if we sketch a normal curve, label the mean and specific x values, and then shade the region of interest, we have a boundary as far as the x is concerned, and we use technology or the table to go to the z-score. As we make that movement, we are using z equals x minus mu over sigma, we get to the same answer. But remember what the area represents. The area represents the probability, and more importantly, how is the area calculated? It is calculated using integration. It's a very long and tedious process. And so that's why there are infinitely many different normal distributions. The moment you change mu or sigma, you have a new normal distribution. But imagine all of them can be transformed into standard normal distribution, and all you have to do, use standard normal distribution and calculate the area under the curve. And that's why it is popular to use it in that fashion.
Heights of men are normally distributed with a mean of 68.6 inches and a standard deviation of 2.8 inches. Find the percentage of men who are taller than a shower head at 72 inches.
What is given? So you read the question, you see that it's normally distributed. You see the mean, you see the standard deviation. You use symbolic format. Mu 68.6, sigma is 2.8. We want to know the percentage of those men that are taller than 72. Probability of x larger than 72. We have to go to the z-score and standard normal distribution. This is what we want. And I don't normally even graph this. I want you to know that. Instead, I find the z-score first. Z equals x minus mu over sigma. 72 minus 68.6 over 2.8. And that gives us 1.2143. For the sake of table, you can stick with 2 decimals, or you can go in between, meaning between 1.21 and 1.22, okay, because it's almost in between. And that's actually a better idea. But in any event, now that you have the z-score, look at the bottom left. Mu of 68.6 inches corresponds to z-score of 0. And x of 72 inches corresponds to z of 1.21. So this is what I mean by graphing. If I'm graphing, I rather graph with the z-score. So instead of using mu equals 68.6, I would use z equals 0, and then instead of 72, I would use z equals 1.21, and I look it up from the table. Take a look at this one again. You can come up with the area. I would rather use just the z-score. In other words, I wouldn't even bother to do this or even this. I would write 0 here. I would write 1.21, and this is my shaded region, and I look it up. This is what I would do. This is the fastest and easiest way to handle this. Now, technology, z-table, as you can see, the numbers are different. And this is using normal CDF. You can write, I mean, again, with the technology, even without changing it to a z-score, you can get it. I highly recommend you always do it, change it to a z-score, because you'll be asked to do so. And the reason the numbers are different than the z-table, remember the z-table has limitations, and the limitations would be to use 2 decimals. But even with that, if you pay attention to the fact that this number is between 1.21 and 1.22, so you look up both of them, and you go somewhere in between, then it will become very close to what the technology gives us. All right, let's go to the next example.
Assume that women spend on average $146.21 per month on beauty products with a standard deviation of $29.44. Find the percentage of women who spend less than $160. Assume the variable is normally distributed.
We read the question and we need to see what is given. So very carefully as we read it, the very first thing we want to make a note of, okay, ND, we are dealing with normal distribution. Mean, sigma, the standard deviation, sigma. So that's the first thing, what is given to us. We make a note of it. And so what we want, find the percentage of women who spend less. If you have X less than 160. If you have X less than 160. Practically we're done because we understood what the question is asking. So all we have to do is to go from X to Z, table or technology, find the answer, you're done. Okay, so X is less than 160. So with that being the case, this is what we are looking for. We find the Z score, X minus mu over sigma. Now, 0.4684, you round it to 2 decimals for the sake of the table. Now, again, I would not bother with this. Instead, I would graph this one. Again, understand the meaning of it and why I have both of them for you, because I want you to understand what's happening as far as, dealing with X versus the Z score. But if I'm graphing to help me read from the table, I would graph the Z score from negative infinity to 0.47. So that means I'm looking for probability of Z less than 0.47, and we can find the answer either from technology or the table, and it is absolutely fine how you arrive at it. All right, we're going to go to the next one. We want to find values from known areas or probability or percentage. Graphs are extremely important for visualization, understanding and successfully working with normal probability so we can find the answer. With that being the case, don't confuse the Z-score and areas. Those are two different things. Z-scores are distances along the horizontal scale, but the areas are regions under the normal curve. Z-table lists Z-scores in the left columns and across the top row, but the areas are found in the body of the table. It's extremely important not to confuse the two.
Choose the correct right-left side of the graph. A value separating the top 10% from the others will be located on the right side of the graph, but a value separating the bottom 10% will be located on the left side of the graph.
If you remember when we did the P10 as an example, if we are looking at the 10% and 10 percentile only, that means the bottom 10% versus the top 10% or top 5%, and you name it.
The z-score must be negative whenever it is located in the left half of the normal distribution. Areas or probabilities are always between 0 and 1, and they are never negative.
Here's the next example.
When designing equipment, one common criterion is to use a design that accommodates 95% of the population. What would be the maximum acceptable height of a woman if the requirements were to allow the shortest 95% of women to be pilots? That is, find the 95th percentile of heights of women. Assume that heights of women are normally distributed with a mean of 63.7 inches and a standard deviation of 2.9 inches. In addition to the maximum allowable height, should there also be a minimum required height? Why?
We are looking at an application, so let's see what's given. Immediately we notice it is normally distributed. Here's the mean, here's the standard deviation. So it's ND, normally distributed, mu is 63.7 inches, and sigma is 2.96 inches. So those are the given we should recognize immediately. Find the 95th percentile. So it's looking at the concept of an area. In other words, this is what we want. The area to the left of some number, x, is supposed to be 0.95. So to do that, the very first thing we do, we ignore the x and we assume it's a z and deal with the z, then we go to x. But for now, probability, again, we deal with standard normal distribution. Z less than some number must be the area of 0.95. And you have to look up the table or just use the technology. And it's a fairly common value. It's one of those values we should know. Looking up the table or technology, even the table has this number. Do you remember the asterisk when I went over the table? You can look it up later on. Z becomes 1.645. So what is missing? X. What I'd like you to see here is that Z score is given as X minus mu over sigma. If we do the cross product, this is Z over 1. So if I do this cross product, 1 times X minus mu is equal to Z times sigma. And you can use negative mu, take it to the other side, make it positive mu, and you get X equals mu plus Z sigma. In other words, given the fact that Z equals X minus mu over sigma, the cross product results in X being mu plus Z sigma. That's a very simple case. Now you have a mu, you have Z, you have sigma, put it in, and it gives us the answer. And the answer can be found here or in this format. You can use the inverse normal distribution using TI. So technology gives you an answer. The table gives you a slightly different answer, very close. And a requirement of a height less than 68.5 inches would allow 95% of women to be eligible as U.S. Air Force pilots. There should be a minimum height requirement so that the pilot can easily reach all controls. So I think having a minimum value makes sense also. And also I'm showing you the Excel technology in case you use that. So this is for those who are interested in various technologies. You can always look them up. If you have access to any of them, that's absolutely fine. TI or Excel or Minitab, or there are more StatDisk. Let's look at more examples.
Assume American household generates an average of 28 pounds of newspaper per month for garbage or recycling with a standard deviation of 2 pounds. If a household is selected at random, find the probability of its generating between 27 and 31 pounds per month. Assume the variable is approximately normally distributed.
Let's see what is given. So the very first thing we are looking for is this, ND. So if it's normal distribution, we need the mu. And then we need the standard deviation, which is given. See, so that's the very first thing, understanding the given. Now it says between 27 and 31 pounds. So we want between 27 and 31. So X is between 27 and 31. So all we have to do, now go to the Z score, everybody. Go to the Z score. And to do that, remember Z is what? X minus mu over sigma. So you have to use the Z equals X minus mu over sigma. You know mu, you know sigma, and plug in number 27, plug in number 31, and calculate the Z scores for both of them. There are values, negative 0.5 and positive 0.5. So now the graph really is referring to the Z score from negative 0.5 to 1.5. That's what we want. So you go through the process to find this. As far as graph, you can even wait until we have, and using the Z scores, okay? You don't even have to graph it with the X scores. In any event, you look it up. I'm assuming everybody can look up the answer. and it's 62.47%. That would be the answer to this question. 0.6247. So if a household is selected randomly, the probability of generating between 27 and 31 pounds per month, that's 62.47%. That's horrible. So what can I tell you? Take care of your environment. Again, statistically, this is a proof that you gotta, watch out for the future, and I mean that. So let's move on.
To qualify for a police academy, candidates must score in the top 10% on a general abilities test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. Assume the test scores are normally distributed.
Let's see what's given. Normally distributed, mean, sigma or standard deviation. So immediately you have to recognize those and say, okay, this is the given. So what is the question asking? That's what we want to know. The question is, we want the top 10%. So the idea is the top 10%. That means we want the probability of Z larger than some number is 10% or 0.1. We find the Z, we go to X, and we're done. So to do that, that's the idea. And again, for now, we really have the Z. So this is 200, X is missing. So we can find the Z then using the Z score such that the area is 0.1. So look at this table, and 0.8997 and 0.9015. The first one is the closest. You can use 1.28, or look at the table, use 1.285. This one is 1.29. This one is 1.28. So we can go in between. Needless to say, the left one is closer. You can say 1.284 or 1.285. That would give you a better approximation. And if you're using technology, you will get a different answer. X, we've already shown that when Z is 1.28, the formula for X is mu plus Z sigma. I went over the cross product and replaced the mu with 200, replace the Z with 1.28, I would say 1.285. And you will get a different answer there when you do 1.285. Try that.
For a medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. If the mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that would qualify people to participate in the study.
Normally distributed. Mu is 120. Sigma is 8. We want the middle 60%. That means right smack in between is mu, then we have 30% on each side. In other words, this is the graph. The total of 60% means 30% on each side of mu means this. Probability of X between the two numbers is 0.6. So what does that mean? You can look for probability between the number and Z score of 0. Remember that you have to calculate that, and it can be done. Is 0.3, look up the table and come up with the answer. So remember this area, if you're dealing with the Z score, this area, 0.5 minus 0.3 or 0.2. So this area, pay attention to this area is point. Why are we using this point, this area? Because of the reading. So you go to the table, you want the area of 0.2, and you read the Z score. I want to erase that because I'm going to put the Z score in a moment. So you want the Z score. From the table, you read negative 0.84. You don't have to read the positive Z score. It's by symmetry, the positive end. So again, from the table, everybody, use a different color here. From the table, using this area, you get this one. From this graph, you have an area of 0.2 to the left. You go to the table and you find the Z score of negative 0.84. By symmetry, the other one is positive. And so, remember, what's X? X is mu. plus Z sigma. You have mu, you have sigma, you plug in negative 0.84 instead of Z, that gives you a value. You plug in positive 0.84 for Z, and that gives you a different value. So that means it's between the two numbers 113 and 127.